Hello everyone, welcome back to Math Verse by Vishal. So in the previous video, we have seen the first five questions of complex numbers part 1, right? Now in this video, we'll try to see the remaining five questions from the chapter complex number, which you must know before going to your JEE Mains second session. So let's take the first question for this video. Now, I'm not saying this is a difficult question here. This is a question which is being asked very frequently in the recent past, that is, last 4 to 5 years. Almost every year, this question is being asked at least once. So, that is why let's try to see this question first. So, given that x square plus x plus 1 is equals to 0, so let's try to understand the first statement, meaning we have the equation as x square plus x plus 1 is equals to 0. So it's a very standard equation known to us. We know that the roots of this equation are nothing but x is equal to omega and omega square. Okay. So for example, I'll take one of the cases x is equals to omega, and even if you take x is equals to omega square also, you will still get the same answer. You can verify that later after this video. So now I'll try to take x is equals to omega. And now let's look at the required part. We have to find out the value of x plus 1 by x whole power 4 plus x square plus 1 by x square whole power 4 and so on up to x power 25 plus 1 by x power 25 whole to the power of 4. So first thing what I'll do is I'll try to represent this entire thing in terms of a sigma notation. So I'm writing it as sigma r is equals to, or some k is equal to, that's up to us. K is equals to 1 to 25 x power k plus 1 by x power k whole to the power of 4. But we know that x is equals to omega from the first equation. Let's take it and substitute it here, from which we get sigma k is equals to 1 to 25. This will be nothing but omega power k plus 1 by omega power k whole to the power of 4. Okay. Now let's try to understand here. So when you expand the sigma here, k is equals to 1 to 25, we get two different types of terms. That is, either k will be a multiple of 3 or k will be not a multiple of 3. So let's see what happens if k is a multiple of 3. For example, k is equal to 3n. So it's a multiple of 3, right? So if k is a multiple of 3, what happens is this will be omega power 3n plus 1 by omega power 3n, right? Because I'm taking k is equal to 3n as first case, which is multiple of 3. We know that omega power 3n is also same as omega cube whole power n, but omega cube is always 1. So in this case, what you get is 1 plus 1 divided by 1, which is equals to 2. So the conclusion here is whenever we have the power of omega in that expansion as multiple of 3, you get the answer as what? 2. That is the value of omega power k plus 1 by omega power k. Now let's see what happens for when k is not a multiple of 3. So for example, if I take one case, let's say k is equals to 1. Okay, if I take k is equal to 1, what I will get here? Omega plus 1 by omega, which is nothing but omega plus. Now we know that 1 by omega is nothing but omega square, but omega plus omega square will be minus 1. So you can check. Even if you take k is equals to 2 also, what will you get here? Omega square plus 1 by omega square. But once again, this omega square is nothing, 1 by omega square is nothing but omega. So again, you will be getting the value omega plus omega square, whose value is equals to minus 1. So what are the two important conclusions here? That is, whenever the value of k is a multiple of 3, then you will get the value in the bracket as 2. Otherwise, in all the remaining cases, whenever k is not a multiple of 3, you get the bracket's value as minus 1. So if you observe from k is equals to 1 to 25, you can count how many multiples of 3 are there. So which will be exactly 8 in number. So I'm writing that directly. I hope you will calculate that. So multiples of 3 will be exactly 8 in number. So each one is giving you a value of 2, right? So it should be 8 times 2 to the power of 4. And plus, what about the remaining value? So out of 25, 8 values are giving you the value 2 to the power of 4. And how many values are remaining? 17, right? So each of these remaining 17 terms are going to give you the value of what? Minus 1 to the power of 4. So which is finally 8 times of 16 plus 17 times of 1. And then you can calculate this value. You will get the answer as 145. Okay. So if you know this idea, that is that taking the case of k is equal to 3n and not is equals to 3n, these kind of questions are very easy. Okay. As I told, this is not a difficult question. It is one of the frequently asked questions in JEE Mains, especially in the recent past. Okay. I hope it is clear. Let's take the second question for this video. Now, it's a pure geometrical application question, and this question was asked very recently in the January 2026 main session. Let's try to see the question. First, the given question is, let Z be the complex number satisfying the inequality modulus of Z minus 5 less than or equals to 3. But if you remember well, I already discussed this inequality meaning in the first video itself, right? So directly I'm going to write. So this is similar to the inequality mod of Z minus Z1 less than or equals to R, where Z1 is equals to 5. And this right hand side part will be the radius. So which means it is representing the interior part and on the circle with whose center is 5 and radius is equals to 3. So we'll take the diagram because it's a pure geometrical application question. So let us try to draw the diagram, right? So center is 5 comma 0, and this is the real axis and imaginary axis. And let's take the circle with center at 5 comma 0, and we have to make sure radius is equals to 3 units. Okay. So if the radius is 3 units, obviously this left extreme will be 2 comma 0, and this will be 8 comma 0. Now this is the meaning of first inequality. Now let's look at the remaining part. We have to Z is a complex number satisfying this inequality and also having the maximum positive principal argument. Okay, we have to be very clear here. Maximum positive principal argument. Okay, so we know how to take the argument of any complex number, right? So we simply join that origin with that point Z, and then we take the angle made by that line with the real axis, positive real axis, right? So moreover here, they are saying the argument of that number should be maximum. And what is the first inequality here? That the complex number Z will either lie on the circle or inside the circle. But clearly, as per the required case, that is, since you are supposed to make it maximum positive argument, you can't take that Z in the below x-axis region, because whenever you take a complex number which is below the x-axis, it will have negative argument. So let's eliminate that part. Now we have to take the complex number Z only on the above x-axis region. And if you think properly, let's say you are trying to take a complex number Z here, somewhere here. But if you try to join this origin with this point here, it might not give you the maximum argument. So by looking at the diagram itself, by now we would have got the idea, right? That this maximum argument is possible when you take this complex number Z in such a way that the line joining this origin and the complex number Z is a tangent to the circle. So which means for maximum possible case, you have to make sure that line joining origin and the required complex number Z could be the tangent to the circle. Because if you imagine any other point which is inside this circle or on this circle, in all the cases, definitely the argument is going to be lesser, right? Because in this case, what is the argument? The angle made here in this way. Okay, you can notice that this is your argument. So only in this case, you're going to get the maximum argument. Okay. Now from here, what I'm going to do is I will take the point Z as some point A here. Okay. Now my aim is to calculate the point A. Okay. So for that, there are different ways. Either you can use the circles concept because it is a tangent line, and you can assume the tangent and drop the foot of the perpendicular from there. But it's a somewhat lengthy question. We can use the concept of complex numbers here. What I'm going to do here is, first of all, we know that this length here is 5 units. You can look at the diagram here. This is 5 units. and clearly this will be radius, which is already known to us 3. So in this right angle triangle, we have 3 and 5 as the height and hypotenuse. So which means the remaining side of the triangle is going to be 4. Okay. So now what I'm going to do is I'm going to write this point A, that is the complex number z, in terms of exponential form r into e power I theta. Okay, this is the exponential form of any complex number, right? R into e power I theta. And what exactly is r here? It is nothing but the distance between origin and that point A, which is clearly 4 as per the diagram. Okay, that's the main advantage here. And then next we need this theta here. So if you observe carefully in this diagram, we can write down tan theta is equals to 3 by 4. And even if you want, you can write down sine theta cos theta as well, because when you expand this e power I theta, you should be writing it as cos theta plus I sine theta. So which is equals to 4 times of. So what is cos theta here? 4 by 5 plus I into sine theta is 3 by 5. And finally, we get the point A, that is complex number z, which is equals to 16 by 5 plus I into 12 by 5. So as I told, there are different ways to get the point A here. That is the complex number z, but this is the best and easiest way to get the point z. Okay, that's the reason I'm discussing this, so that whenever this kind of question comes up in the next main session, you won't do the lengthy method. Okay? Now, once you know the value of z, I think the question can be solved, right? Because if you look at the required part, what do we need? It is 34 times of modulus of 5z minus of 12 divided by 5 into I into z plus 16 whole square. Now already we got z is equals to 16 plus I into 12 whole divided by 5. So take this value of z and try to substitute it here and properly rationalize the denominator, and then calculate the modulus, square it, and multiply it by 34 to get the answer. Okay. Now I'm leaving this solving part for you, and now you try it by yourself and try to get the final answer and verify. Okay. So you have to get the final answer. I'm giving the final answer also for this. You have to get the final answer as 20, and this is a work for you. You can try it and verify. Okay. Let's see the third question, and this is a question from last year JEE Mains 2025. Now, once again, this is a geometrical application question. It can be solved theoretically also, but if you try to use the geometry, it can be done in very simpler way, right? Now, so let's read the question. The number of complex numbers z satisfying the equations. Let's take the first one. Mod z is equals to 1. And one more equation is given as z divided by z bar plus z bar divided by z is equals to 1. So we have to find out how many complex numbers z will satisfy both the equations simultaneously. Okay. So for that, first thing, let's analyze the equation 1, that is mod z is equal to, which is very simple. Mod z is equals to 1 is clearly a circle with center as 0 comma 0, whereas radius is equals to 1. This is very simple. Now, when you go to the second equation here, instead of putting z is equals to x plus iy, okay, so generally when you look at the second equation, you might get the idea that putting z is equals to x plus iy will solve it. But instead of that, let's try to simplify first, then later we'll try to put x plus iy. Okay. So when you take LCM, let's do that. Modulus of z square plus z bar whole square whole divided by z into z bar is equals to 1. Okay. Now, if I try to cross multiply, this will be modulus of. Now, I'll try to put z is equal to x plus iy, that is x plus iy whole square plus x minus iy whole square is equals to. Now, right hand side will be nothing but mod z whole square, right? Because in the denominator, you can notice we have z into z bar. So, z into z bar is mod z whole square. Okay. Now, let's try to simplify this one. So, the left hand side is just like a plus b whole square plus a minus b whole square, which will be 2 times of a square plus b square. That is 2 times of x square plus iy whole square, and that should be is equals to mod z whole square. Now, very clearly here, we know that mod z is already equals to 1 from the first equation, because it has to satisfy both of them simultaneously, right? Which means equation 1 is correct. That is mod z is equals to 1. So you take that mod z is equals to 1 and substitute in the right hand side part, from which you get modulus of x square minus y square is equals to 1 divided by 2, since mod z is equals to 1. And I have taken the 2 to the right hand side here. That part you can notice. And here iy whole square is nothing but I square into y square, which is minus y square. Okay. Now, when you open the modulus sign here, we get this as x square plus y square is equals to plus or minus 1 by 2. Plus or minus 1 by 2. Okay. Now, clearly, you have two cases here. That is why let's try to split the cases. Case 1, we have the circle equation, which is whose center is 0 comma 0, radius is equals to 1. So let's write down that equation as well. X square plus y square is equals to 1. And what is the other simultaneous equation? For case 1, we will take x square plus x square minus y square is equals to 1 divided by 2. So if you draw the diagram, first one is a circle like this with center at origin, whereas the second one is a rectangular hyperbola which will meet the x-axis at plus or minus 1 by root 2 comma 0, because you can solve it, right? And that's the reason you can notice totally how many points of intersections are there, because finding number of complex numbers z satisfying both of them is indirectly what? Calculating the number of points of intersections both the locuses, right? So clearly in this case, 4 points of intersections are there. So case 1 can give you 4 solutions. In the similar way, case 2, if you take, the first equation is not changing because x square plus y square is equals to 1. But in the second case, you must be taking it as what? X square minus y square is equals to minus 1 by 2. Now for this one also, let's go with the diagram. X square plus y square is equals to 1 will be a circle again whose center is origin, radius is equals to 1. But this time, again, we have a rectangular hyperbola, but it is conjugate 1. So you will get a diagram something like this. So even in this case, how many solutions are there? 4 solutions are there, because you can clearly notice 4 points of intersections in both the locuses here. So in total, how many cases are possible? 4 plus 4, 8 cases are possible. So which means you will have 8 points of intersections, or 8 solutions, or 8 complex numbers satisfying both the equations. So as I told, if you try to do it in the geometrical approach, just by looking at the equations also we can say, because we know what is a circle and hyperbola and how to plot it. If you solve it theoretically, you might take one extra minute. That's why you try to remember this method. Let's see the next question. And this is a question from JEE Mains 2024 session. And once again, this is also not a difficult question, but there is a high chance many students will commit a mistake here while taking the magnitude and also argument of this kind of complex numbers. So this kind of questions are asked, they're asked 2 times in the last 2 years itself. So let's try to be very careful with this question. So let's read it. Let r and theta respectively be the modulus and amplitude of the complex number. So let us mention the complex number. What is that? Z is equals to 2 minus I into 2 times of tan of pi pi by 8. Okay. And we have to find out the values of r and theta. Okay. So first thing, what is r? We know that, which is magnitude. So let's find out the magnitude. R is equals to square root of, this is 2 square 4 plus minus 2 tan pi pi by 8 whole square. Now if you calculate this one, so let's do the calculation part also. So this will be square root of 4 plus 4 tan square of pi pi by 8. So if you take 4 common here, you get 2 into square root of 1 plus tan square pi pi by 8. And you know the formula, right? 1 plus tan square theta is secant square theta. It is 2 times of square root of secant square of pi pi by 8. Now here is the step where many of you might commit a mistake. So whenever you have square root of x square, always you have to put modulus of x, right? That is why it should be r is equals to 2 into modulus of secant of pi pi by 8. So if you forget this modulus sign, your answer is wrong. You can't take the answer as 2 into secant of pi pi by 8. And what is the simple reason? Pi pi by 8 is an angle lying in the second quadrant, and secant of second quadrant angle will be negative. So you are going to write r value as negative, which is magnitude not even possible. So that is the, be very careful. Okay. Yeah. Here it's like mod x. So we know the definition of mod x. When x is negative, mod x should be written as what? Minus of x. So you can write the answer as r is equals to minus 2 into secant of 5 pi by 8. So this is the proper way to do this question. Okay. And also, if you do not have this value in the options, you can change by using trigonometry concept, right? I can also write this as minus 2 into secant of. You can write this 5 pi by 8 as 5 minus of 3 pi by 8. And finally, secant of 5 minus theta will be what? Minus secant theta. And you can write down also in this way also, r is equals to 2 into secant of 3 pi by 8. Okay, so as I told, based on the options, we have to proceed for value of r. And then next, coming to the argument. So let's try to recall the concept of argument. We have the simple concept, right? Based on the quadrant in which the complex number is lying, we have the particular formulas, right? If it is first quadrant, you're going to write the answer as theta, sorry, alpha. And then if it is second quadrant, you'll be writing the answer as pi minus alpha. If it is third quadrant, minus pi plus alpha. And if it is fourth quadrant, you'll write the answer as minus alpha. But what is alpha here? The basic formula. Alpha is equals to tan inverse of modulus of y by x. And this is for the complex number z is equals to x plus iy. So this is a standard method we have to find out argument of any complex number. Okay, so let's do that. So here, what is the complex number z? That is 2 minus I into 2 times of tan of 5 pi by 8. Okay. Now you might think that this complex number is lying in the fourth quadrant because you have the what 2 comma minus 2 into tan of 5 pi by 8. Okay. So just by looking at this minus sign, many of you will get confused that this is a point lying in the fourth quadrant, but it is not. Because again, once again, 5 pi by 8 is what? Second quadrant angle. Tan of second quadrant is negative. So negative of negative, which will be positive. Okay. That is why this is a point in the quadrant one. So this is where many of you might commit a mistake. So try to rectify by understanding this. Okay. Otherwise, you can write like this here. Once again, I can write this 5 pi by 8 as 5 minus of 3 pi by 8. If you want, you can do directly in this way also. What is that? 5 pi by 8 is nothing but 5 minus of 3 pi by 8. So tan pi minus theta will be minus tan theta. So minus of minus becomes plus. So this will be 2 comma 2 into tan of 3 pi by 8. But advantage is what? 3 pi by 8 is a first quadrant angle. You can calculate. 3 pi by 8 is a first quadrant angle, which means Z belongs to quadrant 1 here. So in quadrant 1, you can look at this diagram that I have drawn. In quadrant 1, when you have the complex number Z, your argument theta should be directly is equals to alpha. But we know how to calculate alpha. Just now I have mentioned the formula also, which will be tan inverse of modulus of y by x. Y value is 2 into tan of 3 pi by 8 and divided by x value is 2. You can cancel out the 2 here and the remaining part is going to be theta is equals to tan inverse of modulus of tan 3 pi by 8. But once again, here 3 pi by 8 is first quadrant angle as I told just now. But if it is a first quadrant angle, it's a positive value. So you can directly write modulus of tan 3 pi by 8 as tan 3 pi by 8 because mod x is equals to x when x is greater than equals to 0. Now once again here we have tan inverse of tan x concept here, but we know that 3 pi by 8 is lying in the quadrant 1, is lying in the quadrant 1. So whenever we have x in between minus pi by 2 to pi by 2, tan inverse of tan x is always is equal to x, right? So let me mention that if you forgot. Whenever we have x belongs to minus pi by 2 to pi by 2, we can directly write down tan inverse of tan x is equals to x. Okay. And if it is not in this interval, you know how to do it by using graphs of tan inverse of tan x. Okay. So that is why here 3 pi by 8 is in the interval minus pi by 2 to pi by 2. And hence you can directly write your answer as theta is equals to 3 pi by 8. Okay. So once again, you try to go through the question as I already told you where you might commit a mistake. So don't make this mistake when this question comes up in your second main session. Okay. Let's take the last question for this video. And this is a question from JEE Mains 2024 session. And it is one of the good questions which was asked in that year because it's purely geometrical application based question. So let's try to analyze part by part. So let's take the first part. Given that P is a set containing Z belongs to complex numbers such that modulus of Z plus 2 minus 3i is less than or equals to 1. And once again, we know how to simplify this one, right? Which will be modulus of z minus of minus 2 plus 3i less than or equals to 1. So clearly this is the center, right? So center coordinates are minus 2 comma 3. And the right hand side radius is equals to 1. So, and once again we have less than or equals to 1 symbol. So clearly it is on or inside the circle with center minus 2 comma 3, and also radius is equals to 1. So we'll draw the diagram later, but at the same time let's try to discuss about this set Q here. So this set Q is giving the locus z into 1 plus I plus z bar into 1 minus I less than or equals to minus I. Now clearly it is a straight line inequality because it's a standard form of straight line, right? And if you do not know the standard form of straight line, still no problem. Directly you can put z is equal to x plus iy and simplify this one. Okay. So it is x plus iy multiplied by 1 plus I plus z bar is x minus iy multiplied by 1 minus I less than or equals to minus 8. If you expand completely, you will get something like this: 2x minus of 2y less than or equals to minus 8. And I'm leaving the calculation part for you because it is direct substitution. All the imaginary terms will be definitely cancelled out. Okay, keep in mind, whenever we have the straight line of this form, definitely when you expand, imaginary terms, I coefficient will be always 0 when you solve such questions. So after that, you get something like this, right? When you cancel out 2 and send the y to the right side, you can write it as y greater than or equals to x plus 4. Y greater than or equals to x plus 4. And once again, the meaning of this inequality is very clear. It is simply the region on or above the straight line. On or above the straight line, y is equals to x plus 4. On or above the straight line, y is equal to x plus 4. So which means and moreover, let's read the next part of the question because a more interesting thing is given. Let in the set P intersection Q here, okay, which means the first region is represented by on or inside the circle, and second region is represented by what? The region or on or above the straight line. And what is the meaning of P intersection Q here? You must be taking only the common part of these two. So let's now try to draw the diagram, proper diagram for this one. So as I told, it's a pure geometry application. We will try to do it carefully. So what is the center of the circle here? Minus 2 comma 3, and the radius is equals to 1, which means the circle completely lies inside the or in the quadrant 2. Let me mark the center also, which is minus 2 comma 3. Okay. And then the radius is equals to 1. Next one is what? Y is equals to x plus 4. Y is equal to x plus 4. So if you try to plot this y is equal to x plus 4, you will get something like this. This is your straight line. Y is equal to x plus 4. We know how to draw the straight line, right? And then moreover, you have to exactly find out whether the line is meeting circle at how many points. You know the concept, right? If the perpendicular distance from center to the line is less than radius, then in that case it will be cutting the circle at 2 points. So you have to verify that. Okay, in this case I have done that verification part already. So you have to do it by yourself when this question comes up in the exam. Okay, so once again, if the perpendicular distance from center to the line is greater than radius, then the line completely lies inside. And if it is exactly is equal to radius, it will be tangent. And if it is less than radius, it will be acting as a secant line. Okay, so in this case, you will get it as secant. Okay, and then here, now let's understand the region because it is lying on or inside the circle, and also it also needs to lie above this straight line. So since they are talking about P intersection Q, you must be taking only the common part here. So this is your required region because P intersection Q is nothing but common region to both the locus. Okay, I hope you understood till now what is being done. Now let's look at the remaining question because the question is not done yet. That's why I told you it's a very good question which was asked. Now the next part of the question is, let's read it. Mod of z minus 3 plus 2i be the maximum and minimum values of it at z1 comma z2 respectively. Okay. So now let's try to understand the meaning of that one first. If I try to take that modulus of z minus 3 plus 2y minus 3 plus 2y, where z is a complex number which is lying in that shaded part there. Now once again we know how to convert this one, right? I can write this as modulus of z minus 3 minus 2y. So once again it is similar to what expression we know, that modulus of z1 minus z2, right? So which means this here is representing the distance between the complex number z and the point 3 comma minus 2 in the complex plane here. Okay, so that is why let's try to mark the point 3 comma minus 2 also, which will be somewhere here. I will take it as some point P and let us mark the center as C. Now the point P is what? 3 comma minus 2. Okay. Now once again, what is the statement that they are mentioning here? That mod of z minus 3 plus 2y is maximum and minimum at the points z1 and z2 respectively. Now let's try to reflect this question in terms of a few circles based question. So indirectly, they are asking you to maximize and minimize the distance from this point, external point P and that region there. But what do we know about that? Definitely, this maximum and minimum distance occurs along the common normal, right? So you draw the normal. So let's draw the normal to the circle through the point P. Let's do that. We know that the normal always passes through what? Center of the circle. So this is your point P 3 comma minus 2. And this line is acting as normal to the circle. Okay. So very clearly, since the point P is an external point and we have the the shaded part as a part of a circle. So the maximum distance obviously occurs along the common normal in this case. So let me mark that in the diagram. Look at that carefully. So this is the point where you get the maximum. So they said that this maximum is occurring at what point? Z1. Okay. So this is your point Z1. But to get the minimum distance here in this question, don't take it as this point where the line is meeting, where the normal is meeting the circle. Okay, you should not take that because that point Z2, whatever I marked here, is not in the shaded region. Okay, so you should not take that. This is a common mistake. And that is the reason your point of minimum distance is going to be this point wherever the line y is equal to x plus 4 and the normal are meeting. Okay. And then now the method to calculate, otherwise if you want I'll mention like this, z1 is maximum, right? So in the brackets I'll put maximum and here in the brackets I'll put it as minimum so that it will be clear to you. Okay. So Z1 is the point of maximum, Z2 is the point of minimum in this case. Now the remaining part you can solve it by yourself because if you want to find out the Z1, what we can do different methods actually. You can use the parametric coordinates concept. And if you do not want to do that, directly find out this straight line equation through P and C, that is the normal because you have both the points, right? So I'm writing that directly and I'm leaving the calculation part for you. When you solve it, you will get this normal equation as x plus y is equals to 1. So what you do is you try to solve this normal and circle to obtain z1. Okay, and I'm leaving the calculation part to you because it is simple solving of a straight line and a circle. And then next one is what? Z2. So to calculate Z2, what is your obvious idea? You can simply find out the point of intersections of two straight lines, right? So I'm going to mention that solve y is equals to x plus 4 and x plus y is equals to 1, that is the normal, to obtain the point Z2. Okay. And again, once again, I'm leaving the solving part to you so that you can do it later. So once you get Z1 and Z2 complex numbers, you can take them and substitute it here and equate it to what? Compare it with right hand side alpha plus beta times of root 2. And from there, you will get the values of alpha and beta. And at last, you have to find out the value of alpha plus beta. And I'm writing the answer for this once again. Alpha plus beta in this case will be is equals to 36. Since I explained the entire process, your work is only to do the calculation part here. Okay, and moreover, one more thing you can notice here, the two straight lines here are perpendicular to each other, right? So that is the reason Z2 will be the point of intersection of this normal line and the line y is equals to x plus 4. Okay, so I hope it is clear. So these are the questions, important models which were asked in the last 2 to 3 years. Okay, so try to go through these questions and make sure you understand them before you go to your second mains session. Okay.